Have you ever been lying awake at 3 inches the morning with a question you just can't shake? Why did we stop going to the moon? Think about it. In 1969, there was no internet, no smartphones. The computer that took Neil Armstrong to the moon had less processing power than any smartwatch you'd buy at the mall today. And yet we made it. 12 men stood on the surface of the moon. 12. And then, in December 1972, Gene Cernan sealed the hatch of the lunar module, took one last look back, and left. For 52 years, no one went back. Until now. The Artemis program isn't a road trip. It's a commitment to put us back on the moon, to study it, and to lay the groundwork for living beyond Earth. Here's every mission, what happened, what's coming, and the detail almost nobody is talking about. Artemis 1, the 16th of November, 2022. No crew on board. 3 crash test dummies loaded up with radiation sensors in the most powerful rocket NASA has ever launched. The SLS Space Launch System pumps out 15% more thrust than the Saturn V from Apollo. Let that sink in. More raw power than anything that left this planet. In the 50-plus years since we stopped going to the moon, and still they flew it without a crew, because that's what smart space exploration looks like. You don't put human lives on the line until you know the hardware holds up. The mission ran 25 days. Orion traveled 2.3 million miles. It held a distant retrograde orbit around the moon for 6 days. It came home, splashed down in the Pacific on December 11, exactly 50 years after the final landing of Apollo 17. Coincidence? NASA made absolutely sure they didn't miss that date. But there was one detail that changed everything. During re-entry, Orion's heat shield eroded more than expected. Nobody could pinpoint exactly why. And the next mission would have people inside. That didn't stop the program. It changed the re-entry trajectory of the next mission. Because, when you don't know what caused the problem, the move is to eliminate the conditions that could make it worse. If Artemis 1 was the dress rehearsal, Artemis 2 was opening night, the 1st of April 2026. 4 astronauts inside an Orion capsule they named Integrity, beyond low Earth orbit, for the first time in 54 years. Who were these people? Reed Wiseman, commander, Navy pilot, ISS veteran. Victor Glover, pilot, the first black astronaut on a lunar mission. Christina Koch, mission specialist, holder of the world record for longest spaceflight by a woman. Jeremy Hansen, Canadian astronaut, the first person from outside the U.S. to travel to the vicinity of the moon. They orbited Earth first, ran every system on the Orion through its paces, communications, life support, navigation, everything that could go wrong, 250,000 miles from the nearest hospital. Then they punched it toward the moon. On April 6th, at 9:56 a.m. Eastern Time, they broke the record for the farthest distance any human has ever traveled, 252,756 miles from Earth, 406,771 kilometers, 6,602 kilometers beyond Apollo 13's record, from 1,970. They swung around the moon, saw the far side with human eyes live for the first time ever, watched a total solar eclipse from space. 10 days later, they splashed down in the Pacific. All 4 came home. And the heat shield? It's being analyzed right now. Because whatever they find in that data determines whether 2028 happens on schedule. You understand what's on the line here? Artemis 2 was the most expensive test in spaceflight history, to validate a few inches of ablative material. Because those few inches are the difference between 4 astronauts making it home or not. But that's the past. What comes next is where it gets really interesting. Artemis 3, mid-2027. No landing. Not yet. And look, I get it, that sounds like a letdown. But let me tell you what is going to happen, because it's way more important than a landing. Back in February 2026, NASA overhauled the plan. Instead of heading straight for the surface, Artemis 3 is going to test something that has never been done before. Docking the Orion capsule with the lunar landers in Earth orbit. 2 landers, 2 companies. One decision: SpaceX's Starship HLS, a 5.2-meter tower that lands on the moon upright like a rocket out of a science fiction movie. Blue Moon from Blue Origin, Jeff Bezos' project, decades in development, finally getting its shot to prove it can hold up. The Artemis 3 crew will board both. They'll test propulsion, life support, communications, and NASA will decide which one is ready to carry humans to the surface in 2028. It's literally a competition, with astronauts as the judges and the moon as the prize. Oh, and they're also debuting the new lunar spacesuit, the AX-EMU from Axiom Space, developed in partnership with Prada. Yeah, Prada, the most expensive suit ever built for the moon, has an Italian fashion brand's name on it. Because dust resistance in a lunar environment, mobility at 1/6 Earth's gravity, and ergonomics for an 8-hour spacewalk demand engineering that goes beyond NASA's own labs. When Axiom was asked about the partnership, the answer was straightforward. Prada's high-performance materials and functional design are exactly what a next-generation lunar suit requires. Put it that way, and it makes total sense. Still gonna be the most expensive thing ever worn on the moon, by a mile. From Earth orbit, we go to the surface. Artemis 4, early 2028. First human landing on the moon since December 1972, 56 years later. Let that breathe for a second. 56 years. 2 entire generations were born, grew up, and lived their whole lives in a world where going to the moon was just history class. In 2028, that changes. 4 astronauts ride Orion into lunar orbit. 2 of them transfer to the lander, SpaceX or Blue Origin, depending on what Artemis 3 confirmed. And they descend. Destination: the lunar South Pole, the region with permanently shadowed craters where temperatures never get high enough to melt the ice, where water has been sitting there, waiting, for billions of years, where the future of deep space exploration is locked away. They spend a week on the surface, collecting samples, running experiments, walking ground that no human being has ever walked, craters that have never seen sunlight, soil that has never had a boot print in it, and the redesigned heat shield is going to face real lunar return velocities for the first time, with people inside. If it works, history. If it doesn't, that's exactly why Artemis 1 and Artemis 2 existed. Every mission validates the next one. Every calculated risk today is a life protected in 2028. But Artemis 4 isn't the finish line. It's the first step towards something much bigger. Artemis V, late 2028. Another landing, South Pole. 2 astronauts on the surface. More samples. More science. More time. But the real goal of Artemis 5 isn't the mission itself. It's what it kicks off. Starting with Artemis 5, NASA plans to land on the moon roughly once a year, with a funding target between $20 and $30 billion to build a permanent base at the South Pole. Not as a visit, as construction. Structure, power, resource extraction, habitat. The moon as a stepping stone to Mars. Mars as the next question. In December 1972, Gene Cernan sealed the hatch of the lunar module. He looked back at the surface one last time and said, "We leave as we came, and, God willing, as we shall return." It took 56 years. In 2028, someone opens that hatch again, and this time, the plan is to never close it.